Okay. Now here you are seeing three more terms which are displacement, velocity and acceleration. Displacement, velocity and acceleration. Let's see that. See, you are having the particle at point P. You are having the particle at point P. And when your particle is at point P, it is having two projections, one along the x-axis and the other along y-axis. One along x-axis, and that is what you call it as x here, and the other along y-axis, which will be y. Okay, so the projection along x-axis is x and the projection along y-axis is y. Now we'll consider what is x. If the position vector or the displacement vector to the position P is a, and A is making an angle theta with the x-axis. See, here A is making an angle theta with the x-axis. So what will be x? See, adjacent. This is vector A, theta is the adjacent angle. So what is x? X is equal to a cos theta, adjacent side. X equal to a cos theta. Likewise opposite. Opposite will be y equal to a sin theta. So x equal to a cos theta, y equal to a sin theta. Okay, x equal to a cos theta, y equal to a sin theta. What is the reason? Because x-axis is the one which is adjacent to the hypotenuse, but y-axis is the one which is opposite to the hypotenuse, and that is why for x-axis we are taking it as a cos theta and for y-axis it is a sin theta. But what is omega? Omega is equal to theta by time. So what is theta? Theta is equal to omega into time. So I can write, instead of x equal to a cos theta, x equal to a cos omega t and y equal to a sin omega t. So these two are the displacement time equations for a particle which is starting from mean position as well as from extreme position. Now remember, whenever your particle, see, there are only four possible equations here. Which are the four possible equations here? You can write y is equal to a sin omega t. Second equation is y is equal to minus a sin omega t. Third one is x equal to plus a cos omega t. And the last one, x is equal to minus a cos omega t. Whenever your particle is starting from mean position, please keep in your mind that your equation is a sine equation. Whenever your particle is starting from extreme position, it is a cosine equation. So now you are having only two options. When your particle is starting from mean position, it can move to positive extreme. When your particle is starting from mean position, it can go to positive extreme. When your particle is starting from mean position, it can move to negative extreme. When your particle is starting from positive extreme, it can move to mean position. When parting from negative extreme also, it can move to mean position. So only four ways: mean position to positive extreme, mean position to negative extreme, positive extreme to mean position, negative extreme to mean position. Whenever your particle is at mean position, it should be a sine function. So you are having in the first two cases, your particle is starting from mean position. Right, in the first two cases your particle is starting from mean position. In the first one it is moving from mean position to extreme, so it will be y equal to plus a sin omega t. In the second one, particle is moving from mean position to negative extreme, so here the equation will be y equal to minus a sin omega t. In the third one, particle is moving from positive extreme to mean position, so that will be plus a cos omega t. This one will be plus a cos omega t, and the last one is minus a cos omega t. So starting from mean position means sine function, and when starting from extreme position, definitely it will be a cosine function. And there too, starting from mean position to positive plus a sin omega t, mean position to negative minus a sin omega t, positive extreme to mean position plus a cos omega t, and negative extreme to mean position minus a cos omega t. Correct? Okay. Now you know that your equation is x equal to a cos omega t. You are having only two equations here. But when your particle reaches here, x equal to a cos omega t and y is equal to a sin omega t. So here you have got your displacement time equations. Now let's write the corresponding velocity time equations. Okay. Now how will be the velocity equation? You know that velocity v is equal to dx divided by dt. Velocity is equal to dx divided by dt. Or this is equal to d by dt of a cos omega t. d by dt of a cos omega t. When you differentiate cosine, it is minus sine. d by dt of cos theta is minus sine theta, and d by dt of sine theta is cos theta, and one omega will be taken outside, and this omega will be taken outside, and you will be getting what is d by dt of a cos omega t. This will be minus a omega sine omega t. So this is the velocity time equation for a particle starting from extreme, because a cos omega t is the displacement time equation for a particle starting from positive extreme, and v equal to minus a omega sin omega t is the velocity time equation for a particle started from positive extreme. Now your second equation is y equal to a sin omega t. What is velocity? Velocity is equal to dy divided by dt. So this is equal to d by dt of a sin omega t. Again omega will be taken outside, and you will be getting plus a omega. Now what is sin omega t differentiating? On differentiating sin omega t, you will be getting cos omega t. So this is the velocity time equation for a particle starting from mean position. Correct? See, a sin omega t, on differentiating you will be getting a omega cos omega t, and on differentiating a cos omega t you will be getting minus a omega sin omega t. Now you have got the velocity time equations. Let's write the acceleration time equations of these both. See, the velocity time equation was v is equal to minus a omega sin omega t, and here it is velocity is equal to a omega cos omega t. On differentiating velocity, again you will be getting acceleration. So here acceleration is equal to, see, one omega will be taken outside, and it is minus a omega square. What is d by dt of sin omega t? d by dt of sin omega t is cos omega t. So this is the acceleration time equation for a particle starting from positive extreme. Likewise, on differentiating velocity you will be getting acceleration. I'll take one omega outside, and I'll get it as a omega square. What is d by dt of cos omega t? d by dt of cos theta is minus sin theta. So I'll put a minus sign here, and minus sin omega t. So minus a omega square sin omega t is the acceleration time equation for a particle starting from mean position. So you have seen that a sin omega t, a omega cos omega t minus a omega square sin omega t. See, displacement is sin, velocity is cos, acceleration is again sin, and here displacement is cos, velocity is sin, acceleration is again minus cos. See, what is the phase difference between a sine function and cosine function? Basic mathematics. See, the phase difference between a sine function and cosine function is nothing but 90 degree or pi by 2 radian. Likewise, what is the phase difference between plus sine and minus sine? Pi radian. Plus cos and minus cos, pi radian. So between sine function and cosine function is 90 degree. Plus sine minus sine 180 degree. Plus cos minus cos is also 180 degree. Okay. Now you will see here, first one, I am going to draw the displacement time graph. How to draw the displacement time graph? See, let's see let's see the graph where the particle is right now. At time t equal to 0, see, in x axis you are representing time, and along y axis you are representing the displacement. The maximum displacement is amplitude, so it is plus a and minus a, and along x axis we are representing time. I am dividing it into 4 quadrants. The first one is t by 4, the second one is t by 2, the third one is 3t by 4, and the last one is time period. So I am having the entire time period split into 4, which are t by 4, t by 2, 3t by 4 and t. At each time, let's see where the particle is. Now we will substitute for the equation x is equal to, I will substitute for the equation x is equal to a cos omega t. So see, x is equal to a cos omega t. Now at time t is equal to 0, at time t equal to 0, what will happen? At time t is equal to 0, a cos, instead of omega I will be writing 2 pi divided by time period into 0. What is cos 0? Cos 0 is 1. So your first position is plus a. Now at time t is equal to t by 4, at time t is equal to t by 4, it is a cos 2 pi by capital T into t by 4. So t gets cancelled, pi 2 and 2 gets cancelled. So what is pi by 2? Cos 90. Cos 90 is 0. So at t by 4 the particle will reach at position 0. Now at t by 2, it is a cos 2 pi by capital T into t by 2. And what is cos 180 degree? Cos 180 is minus 1. So here you will get it as minus a. Now at time t is equal to 3t by 4, at time t equal to 3t by 4, it is a cos 2 pi by capital T into 3t by 4. So it is 3 by 2 pi. Again odd multiple of 90 degree. So again it is 0. And the last one, at time t is equal to capital T, it is a cos 2 pi by capital T into capital T, and that is equal to plus a. Now please look here. See, you will see this is how you will draw a graph. So when you started at time t is equal to 0, the particle was here. At time t is equal to t by 4, the particle is at mean position. At time t is equal to t by 2, the particle is at minus a. See, negative amplitude, the particle is at minus a. Now at time t is equal to 3t by 4, let's see where the particle is. At time t equal to t by 4, the particle is again at mean position, and at last at the end of one time period, the particle is again back at positive extreme. Now you join all these points and you will get the displacement time graph for a particle starting from positive extreme. Understood? And that's why we have taken the equation x equal to plus a cos omega t here. So clear? This is how you will draw the graph for a particle which is starting from positive extreme. So this is the displacement time graph for a particle starting from positive extreme. Okay? Now velocity time graph. See, this velocity time graph is also for the particle which is starting from positive extreme. So what was the displacement time equation? Displacement time equation is x equal to a cos omega t. The velocity time equation for a particle starting from positive extreme is v is equal to minus a omega sin omega t. Now I will substitute the values of time in this velocity time equations, and then I will get the points for drawing the graph. So your equation is v is equal to minus a omega sin omega t. So at time t is equal to 0, minus a omega sin 2 pi by capital T into 0. So this is at time t is equal to 0. Now what's that? At time t is equal to t by 4, then at time t is equal to t by 2, and then at time t is equal to 3t by 4, and last one at time t is equal to at time t is equal to 1 time period. So now here I will substitute minus a omega sin 2 pi by capital T into t by 4. So this is equal to minus a omega. This is equal to minus a omega. This is equal to 0 because sin 0 is 0. Understood? So at time t is equal to 0, the particle is at position 0. Now after t by 4, the particle is at minus a omega. Now at t by 2, minus a omega sin 2 pi by capital T into t by 2. You will get it again as 0. So after 1 t by 2, after 1/2 of the time period, the particle is again at mean position. Now after 3t by 4, what will happen? This is equal to minus a omega sin 2 pi by capital T into 3t by 4. 3t by 4. See, t and t gets cancelled, 2 gets cancelled, and you will get it as plus a omega minus of minus. What is sin 270 degree? minus 1. Sin 90 is 1, sin 270 is minus 1. So minus of minus will come and your position is plus a omega. Now after the end of one time period, the particle will be minus a omega sin 2 pi by capital T into capital D. This is equal to 0. So after one time period, the particle is again back at mean position. After one time period, the particle is again back at mean position. And this is the velocity time graph for a particle which is starting from positive extreme. Here, seeing this graph, you should not say that the particle started from here. The representation of the particle or the representation of the position of the particle is from displacement time graph, and from that displacement time graph, it is very clear that the particle has already started from positive extreme. This is the velocity time graph for that particle which had already started from positive extreme. Now let's draw the acceleration time graph of the same particle. See, what was the displacement time graph? Displacement is equal to a cos omega c, omega t. So what will be the acceleration time graph? It will be minus a omega square, and again it will be a cosine function, right? Now at time t is equal to 0, this will be minus a omega square cos 2 pi by capital T into 0, correct? You will get it as minus a omega square. So at time t equal to 0, it is minus a omega square. Now at time t is equal to t by 4, minus a omega square cos 2 pi by capital T into t by 4, minus a omega square cos 2 pi by capital T into t by 4. So t gets cancelled, 2 gets cancelled. What is cos 90? Cos 90 is cos 90 is 0. So initially at position time t equal to 0, the particle is at mean position. Now after 1 t by 4, the particle is at, so when you started, the velocity was acceleration was minus a omega square. After 1 t by 4, the acceleration is 0. Now at t by 2, let's see what will happen. At t by 2, minus a omega square cos 2 pi by capital T into t by 2. T cancel, 2 cancel. What is cos 0 is 1. What is cos 180? Minus 1. So you will get it as plus a omega square. It is seen here. At time t equal to t by 2, your particle is at, the acceleration of the particle is plus a omega square. Now at time t is equal to 3t by 4, minus a omega square cos 2 pi by capital T into 3t by 4. Okay. So t gets cancelled, 2 gets cancelled, and your answer is 0 here. Again 0 because cos 270. Now the last one, t is equal to, after one time period, minus a omega square cos 2 pi by capital T into t, and your answer is minus a omega square because cos 2 pi is plus 1. So your answer is acceleration is minus a omega square. Now this will be the acceleration time graph for a particle which had started from positive extreme position, right? Now let's put all these graphs together so that we are getting some other insights also, some other extra evidences we are going to collect from all these graphs. First case, you are seeing the displacement time graph. What was the equation for this graph? Equation was x is equal to plus a cos omega t. What is the velocity time equation of this graph? Velocity time equation is equal to v is equal to minus a omega cos omega t. What was the acceleration time equation? Acceleration is equal to plus a omega square. Sorry, here cos will become sine. Cos will become sine in the second equation. Instead of cos, it will be sine here. Minus a omega sine omega t. And the last one will be again plus a omega square cos omega t. On seeing these equations itself, you will understand that, see, first one is a cosine equation, second one is a sine equation, and third one is a minus cosine equation. See, what is the phase difference between the first equation and the second equation? Phase difference between displacement and velocity. Phase difference between displacement and velocity is pi by 2. because one is a cosine function and the other is a sine function. So from basic mathematics you know that the phase difference between a sine function and cosine function is 90 degree or pi by 2 radian. Likewise another one is a sine function and the next one is again a cosine function. So again the phase difference will become pi by 2 radian. When the phase difference is pi by 2 radian between displacement and velocity, and the same thing the phase difference is pi by 2 radian between velocity and acceleration also, what will be the phase difference between displacement and acceleration? It will be pi by 2 plus pi by 2, or that is pi, and it is very evident from your equations. First one is a plus cosine equation and the last one is a first one is a plus cos equation and the last one is a minus cos equation. See, plus a cos omega t plus a cos omega t minus a omega sin omega t, and the last one is minus a omega square cos omega t. So cos and sin 90 degree, sin and cos again 90 degree, but plus cos and minus cos the phase difference is 180 degree. Understood? Now let us see here. See, what is the similarity between the first graph and the second graph? What is similarity between the first graph and the second graph? Yes. See, if you cut this much portion from the first graph, you are getting the second graph. If you cut the same portion which is corresponding to t by 4 in the second graph, you are getting the third graph. Am I right? Yes. See, here when you cut the first 1/4, I am getting the second graph. Here again I am cutting the second and I am getting the third graph. Means what? 1 t by 4 is the difference between any two graphs. If I take these two graphs, the difference is t by 4. Means if I cut t by 4 from this graph, I am getting the second graph. If I cut t by 4 from the velocity time graph, I am getting the acceleration time graph. How does this come? See, 2 pi is corresponding to one time period. 2 pi is corresponding to one time period. Pi radian is corresponding to t by 2 and pi by 2 is corresponding to t by 4. See, that is the reason here. You know that the phase difference between displacement and velocity is pi by 2. Likewise, the phase difference between velocity and acceleration is also pi by 2. Pi by 2 is corresponding to a time difference of t by 4, and that is why when you cut t by 4 from the displacement time graph, you are getting velocity time graph, and likewise when you cut t by 4 from the velocity time graph, you are getting the acceleration time graph. Now if you cut the first t by 2, if you cut the first t by 2 from the displacement time graph, you will be getting acceleration time graph. The same thing is the acceleration time graph here. So in order to get acceleration time graph and from displacement time graph, you have to cut t by 2 from displacement time graph. So the phase difference between displacement and velocity is pi by 2. The phase difference between velocity and acceleration is also pi by 2. But the phase difference between displacement and acceleration is pi radian. Now when you consider the time difference between displacement and velocity is t by 4, and the time difference between velocity and acceleration is also t by 4, but the time difference between displacement and acceleration is t by 2. I hope it is clear, right? Now the same graph is here. You can see displacement, velocity and acceleration time graphs. See, after each t by 4, if you cut the graph, you will be getting the second graph. Now here if you cut, you will be getting the third graph, and if I cut the first half from this, I will be directly getting the acceleration time graph. Okay, I hope it is clear to you, right?